Hi, welcome back to Mr. Slover's Math. Today we're focusing on story problems, but story problems that require a systems of equations to solve. So we got a warm up to get us thinking about things. State the operation associated with each word. Since we're doing word problems, we should probably refresh our memory on what some of these operations are. So when we see the word sum, it means plus, we're adding. Difference means subtract or minus. And product means we're multiplying. And down here it says translate the following verbal equation into an algebraic equation. The difference between two numbers is 50. Now it doesn't say what the two numbers are, so we use x and y. We're using two different variables because it doesn't say they're the same numbers. It just says two numbers. Their difference is 50. So x minus y, difference is subtraction, and then is means equals 50. And that was all I was asking you to do. So with that, we're going to get into some word problems. It says write a systems of equations based off the given information, then solve. So I'm not asking you to guess and check in your head or on a calculator. Why, yes, that does work. Asking you to create a system. It is more efficient use of your time. The difference of two numbers is 4. So the difference of two numbers is 4. Difference, I underlined, is subtraction. So I'm going to minus. It doesn't say what the numbers are. It just says two numbers. It doesn't say the same numbers. It says two numbers. So that's why I have two different variables. One's x, one is y. Is 4 means equal. Second sentence. Their sum is 18. So the sum is addition. Is means equals and 18. Now, it didn't say we got new numbers. It just says the difference of two numbers is 4, and then their sum is 18. So those same numbers, x and y, now add to give us 18. So here's my system. It's set up, and it looks like it's set up for elimination. I have a negative y and a positive y. I have opposites. So I'm going to add going down, just like my note says here. 1x plus 1x is 2x. My y's eliminate. Negative 1 plus 1 is 0. That's why I don't have it over here. And then 4 plus 18 is 22. And I divide, I get x is 11. So now I'm going to take x is 11 and plug it into the equation. And it doesn't matter which one, just like I said here. 11 plus y equals 18. Subtract 11 and I get 7. So my two numbers are 11 and 7. Well, let's double check. What is 11 plus 7? 18. What is 11 minus 7? 4. So I answered the question. Letter B is the same thing, just different numbers. And the difference of two numbers is 6. So two different numbers equal 6, and we're going to subtract them. Their sum, adding, is 30. So I set up my system, and it's set up for elimination again, and I add going down because I have opposites. Negative 1y plus 1y is 0y. My y's eliminate. 1 plus 1 is 2. 6 plus 30 is 36. I get x is 18. And once again, I plug it into either equation to solve. It doesn't matter which. And I get my other number to be 12. And then I just take a minute, actually not even a minute, 30 seconds to double check. Difference of two numbers is 6. 18 minus 12 is 6. Their sum is 30. 18 plus 12 is 30. So it took about 30 seconds. You can just plug it straight in your calculator. It works. So that was example 1. Example 2 is the same concept, but this time there's, as you can clearly see already, there's more work involved because it's not just using just numbers, finding the difference or adding. This time it's a story problem. So your friend Jay is the assistant manager at AMC in Sunnyland. The movie theater sold a total of 650 tickets Friday night, and that the total sales was $3,675. Jay also says that an adult ticket costs $7.50 and a student or a child ticket costs $4.50. How many of each kind of ticket were sold Friday night? Now, yes, in the real life, the computer or the cash register probably would have this information, but let's say that it didn't. Let's say that it lost the data and you just had the total amount of money, but you didn't know how many tickets were sold for each, and you needed to figure it out. This is where this comes in. You are going to create a systems of equations. So now I have to identify what x and y are, or whatever letters you want. I'm just choosing x and y because in example 1 we had x's and y's. It may be logical for you to say A for adult ticket and S for a child or a student ticket. I don't know. That's up to you. So I define my variables. Now I'm just going to go back and I reread it. Told me that the movie theater sold 650 tickets. The total sale was $3,675. And then I have money again with money. There's a good chance that all of your money is going to go into one equation. So $7.50 for an adult, and then $4.50 for a child or student. We add those together, and that equals $3,675. Okay, so this is all money. Talking about money, $7.50, $4.50, $3,675. The second equation, because we need two, we're writing a system. We need two. The second equation, well, this other number that they gave us, 650 tickets. We're trying to figure out how many tickets of each type were sold. So I don't know how many adult. I don't know how many student or child. But I do know that together they equal $650. So that's what I did. I went ahead and I solved, or I set up my equation. Now, I need to solve. Right? I can't just add going down. It's not going to work. Right? So what I need to do is I need to create opposites. And you can do that any way you want to if you want. Or I chose elimination. And some of you did this on a previous assignment where I chose substitution, where you chose to solve for one of the variables. And that's what we're doing here. I'm choosing to get y all by itself. So I'm going to subtract x from both sides. So I'm going to do minus x, y equals 650 minus x. So now that I have y solved, I'm going to use substitution to substitute that back into my equation and solve. So 7.5x plus 4.5, and instead of a y, I'm plugging in this information. And then I'm going to distribute. I'm going to collect like terms. 7.5x minus 4.5x. They're on the same side of the equal sign, so I can combine them together just like it's printed. Subtract 2,925 and divide by 3. Once I get my answer of 250 for x, I plug that in where I see the letter x. The bottom equation looks easier to work with. So 250 plus y equals 650. I subtract 250 and I get y is 400. So what this means is that Friday night, there were 400 student or 400 child tickets that were sold and 250 adult tickets that were sold. So all of that is going to meet this criteria, 400 and 250, 650. If I were to plug these into this top equation, I would end up getting $3,675. So this example is a bit more involved than the last few, but it is manageable. Break it into manageable pieces. Read a sentence, read two sentences, underline the important information, try and write down an equation if you can based off that one or two sentences. Letter B, same idea of ticket sales, but now a little bit different. So Jacob is selling tickets to a choral performance. On the first day of ticket sales, he sold 9 senior citizen ones and then 12 student tickets for $246. Second day, he collected $43 by selling 3 senior citizen tickets and 1 student ticket. What was the price of the ticket for senior citizen or student? Now, in the previous example, we put all of our money ones together. We can't do that because it doesn't make sense to do that. Okay? He earned $246 that day by selling 12 tickets and 9 tickets. So that right there tells me there's one of my equation. 9x plus 12y equals 246. I have x as my senior citizen tickets and y are my student tickets. The next sentence, he collected $43 by selling 3 senior citizen tickets and 1 student ticket. And that was $43. Once again, we're going to use substitution to solve. There are other ways, like I mentioned in letter A, you could have used elimination, but you'd have to do something else to eliminate for the opposites. So we're going to use substitution. We're going to solve for y. So we're just going to subtract 3x from both sides. 43 minus 3x stays just like that because these are not like terms. So I get y equals negative 3x plus 43. So where I see a y in the top equation, I need to substitute in negative 3x plus 43. And I have to use the top equation because I solved this equation. So I can't plug it into where I just solved. It wouldn't make sense. I have to plug it into the other equation. So I plug it in, I distribute the 12, I collect like terms, and I keep solving, and I get x is 10. And I take x is 10 and I plug it in where I see the letter x. So 3 times x, which is 30, plus y equals 43, and I subtract. So I have 10 senior citizen tickets that were sold and 13 student tickets that were sold. And then I got to think to myself, does that make sense? Does it make sense that that is the price for the tickets? $10 for a senior citizen ticket and $13 for a student ticket. Yeah, that seems reasonable. Now, if you ended up with like $1,000 for a senior citizen ticket to a choral concert at the high school, that wouldn't seem right. Okay? But these do seem logical. So when you work through the word problems, make sure that you read what it's saying. If need be, you can underline. If need be, you can highlight. Break it into manageable pieces. Just like I did here, I took one sentence and I wrote out one of the equations.